Okay, so today we're going to be talking about generics, and to introduce the topic, why is it, interesting to work with those generics? Well, we've used generic classes like ArrayList. ArrayList is a generic class because we can specify data type for it to work with, and then that's what the generic means. But I'd like to show you something else that we haven't seen so far. I don't have to have the whole class to be generic. I need just one method to be generic, and I'm going to make one method generic, not the whole class. And that's what we're going to start with. And then later on, we're going to make a class, the whole class, to be generic, and we're going to be working with those generic classes. So let's start. Now imagine I would like to find, let's say, write a method that finds the maximum of 3 numbers. So you give me 3 numbers, and then I'm going to just return the maximum of those 3 numbers, or maybe display the maximum of the 3 numbers. So what should I do? Let's say if I'd like to have a method that I would like to call, let's say I'm going to call this method by just doing something like this. The max is, and then I am going just to call something called max and give it like 3 numbers, 2, 4, 1. Now this max needs to be obviously declared, right? So I'm just going to declare this by creating this method max that takes 3 ints, because that's what I'm doing. And this is just going to prepare this for me, and I'm not going to return a string, I'm just going to return an int, and then the int is going to be displayed. Now I'm going to call these n1, n2, n3. So how to know which one is the largest? Do while? Do what? While? What? What should I repeat? Yeah.
Declare a variable called max.
You would like to have a variable called max?
Yes, inside the method.
Mm-hmm.
Then or maximum, and then it will take the first int of the first.
You mean n1?
Yes, it will be n1.
Okay.
Max will be n1, and then compare it to n2 and n3.
And then do what? If what?
N1 is less than n2.
Less than n2?
Yes, n2 is max.
Then the max is n2.
And n1 is the n2 and n2 is the n3.
Okay, but he did not finish. Let's that's it.
No, then another else if.
Another else if.
N1 is less than n3.
Less than n3.
Yes. N3 will be max. So max will be equal to.
So max is be n3,
Yes.
and then return the max. What do you think? Is this okay?
So there's N2 and N3.
Yeah, the n3 is bigger than
Now we're putting n1 into max. So if n1 is smaller than n2, then we say n2 is the max. And then if n2 is the max, because of this, am I going to ask this question again? No. I'm just going to move out and return n2. I did not even check n3. Maybe n3 is the biggest, but just here I checked these two, and then I decided that okay, that's fine. Well, that's a nice try, but it's not going to work, especially if the last one is your max. I'm going to run this. It's going to give me that between the two, n2 is bigger, so yeah, the max is going to be n2, and it's going to give me n2, but this one is never going to be executed because this one is smaller than this one. And did I run? Or yes, still running. So this is not going to work out. So it's going to tell me the max is 4, which is not okay. Yes. If I make it what? N1 is bigger than N2. You want to change this? and bigger than nt, same thing that you wanted to say.
And 1, yes.
Well, something similar. And
N2 are bigger than N3.
n2 bigger than n3, then
N1, max equal.
the max is n1.
No, N1 bigger.
You would say n1 bigger than n3.
N1 is
So n1 is bigger than n2 and n1 is bigger than n3. That means, well, obviously, now n1 is the max. Else if, maybe do the same, but this time with n2. If n2 is bigger than n1, n2 is bigger than n3, then the maximum is going to be n2. Else, I don't need to ask any questions, the max is n3. I don't need to put anything here, just declare it, and then I'm going to put something in it, in one of these. This is going to be okay. Right? What I can do, I think what Yusuf was trying to do, I can just ask like 2 by 2 questions. Let's say I'm going to assume that n1 is my max, but let's just keep this and keep it as a comment, because I'd like to show you the other way, which is I'm going to assume that the max is n1, and I'm going to see is n1, or maybe the max, is it smaller than n2? If it's the case, the max should be n2, right? Now I'm not going to put else. I'm still now need to compare with n3. I'm going to ask, is the max smaller than n3? If it's smaller than n3, then the max should be n3. And then I return the max. Now let's have a look at this. Now my max is going to be n1, which is 2. Is 2 less than 4? Yes. So now the max is 4. And then I come back here and ask, is 4 less than 10? Well, yes. So now the max is 10. So it's going to give me the maximum. So there's another way, without this and, that is going to give you this. If we change the max to be the second one, let's say, I'm going to put 2 into the max. Is 2 less than 40? Well, yes. Then 40 should be the max. Then I come back here. Is 40 less than 10? No. So the max stays at 40. So it will always give me the max. So that's another way how to get the max without doing this if else, this all and this might be confusing. Well, whatever. Both of these are methods that are going to work. That's not the purpose of this whole discussion. I'm just trying to refresh your memory on how to find the maximum of 3 numbers. Now, which one you prefer? This one or this one? First or second? This is the first, and this is the second. Just say 1 or 2. Just raise your hand so I can see. Okay, I would like to keep one of these. Or I don't know. I'm going to keep this one. Why? Yes.
It will depend on the amount of ints.
It will depend on the amount of ints. What do you mean?
Maybe the user will enter. In this case, we entered only 3.
Yes.
Very 3 numbers.
Well, we limit ourselves to only 3 numbers. Okay. We don't want to do more. We can do more, but then we have to use an array, and then I don't want to do that for now. I just would like to make things simple, but maybe we could use an array later on. Now, what I'd like to show you is that this is working for ints. What if now I'd like to find the max of, let's say, double values? What should I do? Same thing, copy, paste, and then instead of int n1, I'd like it to be double n1. Everything should be now double, and I'm returning double, and everything is going to be double. Right? This is the only change between these two codes. And if I want it to be float, or fine, or maybe long, fine. It's all these. I will have to just change this to be now long, 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 and you got the point. You see, this is all max, but with different signature, because some of them are int, some of them are double, some of them are long. Is there a better way than just copying and pasting with different data types? Yes, there is. I can make this method generic by saying, well, no, this here will be specified later. How can I do that? Well, I just need to remove this. Now this int here, I want it to be variable. It can change from int to double to long to float to whatever. So to do that, I'm just going to make it, give it a letter. E, it's just, you can give it any type. Let's say T for type or data type. So this is T, T, T. That means the same data type here, and I'm going to declare max to be the same T, and I'm going to return T. Okay, but T, what is T? Now to tell that T is some kind of a variable that is going to be defined later on when I'm going to call this method, I do it this way. But now I have a problem. It tells me, well, how can you have this lesser than in T? Compared to. That's what I can do. I can have this compared to, and then in this compared to, I'm going to say, because I wanted to have this sign, so I'm just going to make it like this. And same thing with this 3. But hey, it does not work this way. So because now when I say something like this, I'm saying this can be any data type. And again, you remember these generic methods, they work only with class data types. They don't work with primitive data types. So this is something that is not going to be working fine. Well, before talking about that, would like to say that this T should be like a data type, but not any data type. I want it to be some kind of data type that is going to be comparable. This is a method that is going to be used based on anything that is going to be comparable. This T now, I'm not accepting any type. I'm only accepting some types that are extending comparable, that are implementing comparable as an interface. We don't, extend an interface, we implement an interface. But when I say something like this, I'm saying that I'd like to put a condition on this type that I'm going to use, that this type should be of a comparable, so I can have access to this compared to, which exists in comparable. Now as you can see, now this is going to work even if I do something like now this is going now to call the one with double. If I run, it is going to work with double. If I remove these, now it's with an int. Now if I have another type, it could be another type as well. But notice one thing. I created this method and I made this data type to be variable. It can change. But to mention that it can be changed, I put this like variable that I use here for data type. By the way, you can choose any name you want. It can be a long name like my data type. So any data type that you use here, the same data type is going to be for N1, same data type for N2, same type for N3, is the same for max. But then this should, the only thing that I need to put a condition that this data type should extend comparable, because I'll need this compared to be available. But generally we use these letters like T, E, and things like that. Generally T is for the methods, like for this means like a type. Another example. Let me give you another example, maybe less complicated than this one, that I should have started with at the first place. Okay, now imagine I have an array of ints. I'm going to call it int array new, or maybe just let me put the values in it immediately. 1, 2, 3, 4, 5. Okay, now I just would like to have something that's going to be show array, and I'm going to give it this int array to display. Now this show array is going to be a void method that is going to just was put in the bottom. I would like to put it here. Now this takes an array, and I'm just going to display that array. Array.length, and I'm going to display that array. Is that okay? That's all I'm doing. Which means if I run, I don't want to do this anymore. I'm just going to run this one. Now this is going to display the array. Now what I would like to do is, if I have an array of double or string, I would like to use the same method. Can I use now the double array here? No, I can't. I need to make this to be, what is the name again? Generic. I want this to be generic, so what I should do, I would like to change this to any data type, so I'm going to put t here. But yeah, I don't have t. What is t? I just, you see, before this return type, I'm just going to put less than t greater than. Now what does this mean? This means now that this is going to be working with any data type. But yeah, I said any data type, but still this one now shows a mistake. Why is it a mistake? Because what is the data type of this int array? It's a primitive data type int. When we said that this doesn't work with primitive data types, it works with class data types. So, well, I have a class data type that is going to be the equivalent of the primitive data type. This is the integer instead of the int. And same thing here, the double capital D, this is the class data type with this one. Why is it not? Because yeah, not all of them are double. So now it's fine. I can have a third one which could be even a string. Well, this is a problem because it's the same name. I'm going to call it a string array. Now, as you can see, this now, it can work with any data type, regardless, because now what I'm saying is has to be some kind of an array of any data type, and I'm just going to display it. Now this, if I run it, I'm going to display each one of them. So this is one way to do that. Now this here is basically the same example, except that I'm putting a condition on this type, and I'm not accepting any type here. Here I can accept any type, but here, like, because there's no condition here, there's no extents. But if I want specific subclasses or specific classes that implement some interfaces, I just put that after the extents, which put like some kind of a restriction. Only those classes that are extending those comparable that are going to be able to be like this type t. And now if I put, now this is int, that means everything is going to be int. If I put it like a string, now everything is going to be string. All the t now are going to be changed to string, to int, or whatever. And I can use the same thing here with the string. I can just compare now with the maximum between these things. Let's say, let's compare the maximum between those. Is that okay? Well, yes, I can, because the maximum here just accepts any type as long as it's the same type here. If it's a string here, it should be a string here, it should be a string here. I cannot just have different types like this, but actually it just accepted it because this is converted to int, and int is comparable, so it was accepted. But how to compare an int to is going to raise some kind of an exception. But let's just run this with the same data type, and you can see that this is going to display the whole array because of this show array, and the max is Muhammad because among the two Muhammad comes after. And that's the generic method. It's a method where the data type is not known. It will be known only when I use that method. Based on what? Well, based on the arguments that I'm going to give it to. If I'm giving it some kind of arguments, the data type of that argument is going to define what is the data type that I'm going to use it with. This makes a lot of sense, especially, for example, if you remember, we were using like this sorting. Now, sorting ints or sorting arrays or sorting anything, well, it should be, I can write like the same algorithm that is going to sort any type of data type. So it will make sense to have a generic method, selection sort or bubble sort, that is going to be able, that's the only thing that it needs to be is just it needs to extend comparable, because I need this compared to. And then once I have the compare to, I can just do anything else. Yes?
Can you explain why you write compares to?
Compare to? Because if I don't use compare to, I'll need to use the less than and greater than, right? That's what was there before. But this is not okay. Why is it not okay? Because max now is a class data type. It's type T. T is a class. It's an object. And N2 is another class data type of type T. This less than and greater than works only with primitive data types. So I need to use the compare to, like what we used to do with the array list. But if I use something like this, compare to is not available, because when I do something like this, any class is possible. You can put any class, as long as it's a class, you can put it as a data type here. But I don't want that. I want specific classes that can have compare to. So which class has compare to is a class that extends, that implements the comparable interface. So that's why I need to mention that the T now that I'm accepting here, it has to be comparable. And a string is comparable because it is implementing, you see, Java implements serializable comparable. And by the way, comparable is an interface, but it's also generic interface, because if you go down, it's compared to whatever data type T that you're going to use. And what is T? It's the data type that you're going to give me as the other one that I'm going to compare to. But it always returns an int, because it's all either 0, -1, or +1, something like that. So actually we've been using generics even before we knew them. Comparable, we used it a long time ago, and it was a generic interface. So that's the main idea. Now, to go even further and to benefit, to design some more different generic classes, I can define the whole class to be generic, and I'm going to call it my generic class. Now this generic class means basically I can specify here, as you've seen, or interface, I can specify, I can also use T, it doesn't matter. T is just a letter, but generally if you look around in the documentation, T is kept for methods. If you'd like to have like a generic method, you mention T. if you have like to have some kind of a generic class, they use another letter, which is E. But at the end, it's the same thing. You can use T. I'm going to use T. Now, this becomes like a type. I can have private T, my variable 1, and I can have a constructor that is going to initialize that one. As you can see, just going to take T variable 1, and this is going to be the put inside the instance variable. I can have a toString that is going to be displaying this is the class, generic class, with this variable 1. Now what if I have two variables? Well, we can put another one. This one is going to be the data type that is going to be specified, but I'd like to have another one which is going to be int. There's nothing that prevents me from having a mix of these kind of data types. So this is like a counter. I don't know. So basically, I'm just going to say counter plus plus. And you know what? I'm going to delete the toString. So when I generated it again, it's going to tell me. Why did I have a nice? No, I just would like to insert. And then the toString, yeah, I'd like to show them all. So now it's the variable 1, then the counter, whatever. And then, you know what, I'm just going to increment the counter before, so just to make it change. Every time I do something, I just would like to use the counter. Now, I can use setters and getters with this variable 1, which is type T. I can have a setter and getter, I'll check that. I just select this T, variable 1, which is type T. I would like to have this setter and getter, and I'm going to get variable 1, set variable 1, and you see get variable 1 just give me that, but I'm just going to everything I'm going to increment the counter just for fun. So when I display, I'm just going to display whatever. So I can set the variable 1. As you can see, T now is like a data type because it's specified here. I can change it by pressing Ctrl R. I can make this now to be E. This is what generally you can find in all the documentation. That's why you find E. And that's what it works. It's basically the same idea. It's a data type. I'm returning that data type. Okay, what is that data type? Well, when I'm going to define an object from that class, this is my generic class. When I'm going to define an object, then the data type is going to be mentioned. If I don't do anything, and I do something like this, now you see this takes now an object. So what is the object? I'm going to, I don't know, whatever it is. You know what? I just new integer with 5. So I'm just putting this new integer, which is going to be put inside this here. But now this here is type E, but I did not mention E. When I don't mention E, by default, E is object. The proof of that is that, you see, I said that the constructor is going to be E of this variable 1. What is the object of the data type of that variable 1? And you see, as soon as I use this constructor, what is the data type of variable 1? It's object now, because I did not mention anything. But what if I mention now, instead of being like this, I'm going to mention, okay, I want it to be an integer. Now, as soon as I would try to use the class, well, you see, there are two ones that I need to use. But first of all, if I'm using this one, now this, if I don't do anything, you see, if I use this one, this is still going to be an object, the one without anything. But if I use this integer, now what I need to have, I need to use some kind of an integer value. I just wanted you to see it, but the autocomplete did not want to help. So if I use this, and it doesn't have much. I just want to see that, but it doesn't allow me to see it. But anyways, if you use this integer or like this, like a shortcut for it, now all I can put is an int. If I put something like a string, as you can see, it's not going to be acceptable, because it will tell me Incompatible types cannot infer type arguments for generic class. Reason: inference variable e was incompatible bounds. So equality constraint is integer, and then the lower bound is string. What was given is a string, but it looks for an integer. But if I put 4 or a new int, which is basically the same thing, 4, this is going to be the same, is okay. But if I make it double, now this is going to tell me it's incompatible type. It's expecting an int, I'm giving it a double. Now let's put 4, and now what happens when I put 4? Now this obj dot, you see, if I get the variable is going to be an int. So this variable 1 is now an int because I specify the int. And if I'd like to display that obj, I'm going to expect to have, like, this is going to be, this is the obj, the counter is 2, and the variable 1 is 1. I don't want to have those. Let me just, yeah, so not to have that distraction. So this is the class, this is the variable, and then this is now an int. It can make it a student or whatever. It's up to me to whatever I'd like to put. So it just can be anything. Now there's one thing that I would like to show you. What if I would like to have two data types? One of them is an int, the other one is a string. Now for example, I have these two. This one is going to be a variable e, but I would like to have another data type, variable 2, to be from another type, not e, maybe some e2 or something like that. Well, no problems. You can just put e1 or e2 like this. Or you can give it another letter, which is generally what you can find, e or t or k. Or so now k is another variable too, and I can just, now when you initialize, you can initialize. I'm just going to do that, and can you put also k for variable 2. So now you give me two things, this one for variable 1 and then variable 2. K should be capital. And now I'm doing two things. I can have these getters, make it final. No, I just would like to create some getters and setters for those. So I can see that I'll insert, and then getters and setters for this variable 2. And the toString, I'm just going to remove it because I'd like to insert the new one, which is going to include all of them. So it gives me variable 1, variable 2, and then the counter. And each one of them is going to be having a different data type. But now if I run this, I cannot, because you see now, this does not accept one data type. It needs two. Wrong number of type arguments. It's required two, not only one. So now I can just give it the first one, the second one is going to be string, for example. And this is now how I can now specify different types. This first type is going to be for the first, this is the first e, so now this e is going to be the integer everywhere, and then the k is the second type, and if I mention that the second type is string, now this k is going to be string everywhere. And that's how you can design some kind of generic class that is going to work with different data types. Is there a limit? Can you have only two? No, you can have as many as you want. It's just going to make it kind of hard if you have like more than 3, but still it's possible to have more than 1 or 2 types or 3 types, etc. You just need to put them between commas and give it a letter, a different variable name for that type. That's pretty much it. That's the main idea behind those generic classes and generic methods. The same thing applies here if I'd like this to be extends, just comparable or some kind of different subclass. I can do that. Now only this e, I put a condition, can be only something that extends comparable, while the k, it can be anything. Or I can just, this has to extend some other type of classes. Yeah. Of a counter, just a variable, that is just to show you that you don't have to, in one class that is generic, to only have generic variables from generic data types. I can have any data type here. I can have any kind of data type that I want. I just show, this is just an example. It's not meaning. You can remove it, doesn't matter. So that's all about it. So well, let's do some exercises like the ones that are on the website, so we can just practice working with those generic methods and generic classes.